I welcome you to Mathematics Immunity. Let's get to the class. Now we have vector components, and a unit vector is any vector whose magnitude is unity, and the unit vectors 1, 0 and 0, 1 are in the positive direction of the x-axis and y-axis, and they are called the base vectors. Now the unit vector along the x-axis is represented as I, while the unit vector along the y-axis is represented as j. So we have that I is 1, 0, while j is 0, 1. What do I mean? This is the representation of vector in column form. The x component of I is 1 and the y component is 0. So when you say magnitude or size or modulus, we mean the same. This double line means modulus of I is the square root of the square of the component of x and the component of y. For the I vector, the component of x is 1 and y is 0. So 1 square plus 0 square gives you 1 plus 0, and that is 1. So you can see the magnitude of I is 1. That is why we say unit vector's magnitude is 1. Similarly for j, and j is along the y-axis and I is along the x-axis. Now we are on the Cartesian plane. That's your one x-axis graph. So for I, when x is 1, y is 0. When x is 1, y is 0. For j, when x is 0, y is 1. When x is 0, y is 1 for j. These are called the base vectors. If a vector A is represented in column form 3 and 4, now how do we express this? In component form. In component form is when it contains the I and the j unit vectors. So vector A is equals to 3 times 1 and 0 plus 4 times 0 and 1. If you look at this, 3 times 1 is 3 and 3 times 0 is 0. So it's still 3. 4 times 0 0. 4 times 1 4. So now 1 0 is I, y 0 1 is j. So in component form, vector A is equal to 3i plus 4j, and in column form is like matrix form 3 4. Now let's quickly look at position vector. P is a point x comma y on the Cartesian plane, origin 0. When you have a position, a vector is a coordinate point P, when x is x and this y. So now we have said in our last video that a line with arrow showing direction is used to represent vector. So a position vector is a vector that is represented from the origin 0. So this displacement vector A is the position vector OP, and you can see that OP is xy in column form, and this is the component form. So we have that the modulus of A is the square root of x squared plus y squared. Example: A is a point 5, 3 and B is -4, -5. Find the column vector AB and express AB in terms of I and j. Find the column vector AB. Now coming to the Cartesian plane, when x is 5, y is 3. This is the point A. When x is 5, y is 3. And B, when x is -4, y is -5. That is -4, -5. Now to get your vector, so we join this vector OA and this vector OB. So now you now join this to have your AB. This is your vector AB. So AB is coming down, your arrow comes down. So for vector BO, or you call it OB, OA, or AO, anyhow you want it, you label your direction, you have the same result. So now let's say this is vector OB because it's a position vector. OB is a position vector. The origin is 0. Any vector that takes origin from the 0 is a position vector. And vector OA is coming this way. So now look at this diagram. From the last video, we had a sum and difference of vectors. The triangles represent, the size of the triangle represents the vectors. So now let's look at this diagram. So OA is going the same direction as AB, while OB is contrary. So your OB will be the resultant vector. A resultant vector is a single vector that is a sum of other vectors. So OA, vector OA plus AB, since BO is contrary, BO is contrary, so OB is contrary, and that's the resultant vector. So it's equals to OB. So column A vector AB will now be OB minus, that is negative of OA, negative. So, and unit vector OB, that's your minus 4 and minus 5 as a column vector, negative of OA, which is 5, 3. So we have minus 4 minus 5 minus 5 negative of 3. So I have this way. So AB is equal to negative 4, negative 5 give you negative 9, and negative 5, negative 3, negative A. This is the column vector AB. So without your Cartesian plane, you realize that AB is actually position vector B minus A. And that B is also OB as a position vector. If it is vector BA, it's going to be A minus B, and A is OA minus OB as position vectors. But from the diagram here, we have this. So as the B part says, as a component vector, so we have it as minus 9, 1, 0, plus negative of 8, 0, 1, minus negative of 9, 1, 0 is your unit vector I along the x-axis, negative of 8, J is the unit vector along the y-axis. In the next video, we'll be having more examples and exercises. But if you have questions from me, this is my email account, alberttoba@gmail.com. I'll respond to your messages. Then you can also make comments, and we look into them. Thank you. Come to the end of the class. See you next class.